right, so I'll start right now. All right, hello everyone, and welcome back to the second workshop in the ICP Chain Fusion Web3 Collision Hackathon series. And I'm Kaden, and your host for today's ICP Hackathon workshop. It's great to see so many familiar faces as we dive deeper into the world of Web3 on the Internet Computer Protocol platform. Today, we are focused on one of the most exciting and essential components of ICP, which is the Canister smart contract. They are a core part of the Internet Computer Protocol, and understanding them is key to building a successful project on this platform. We are lucky enough to have Elias Detler from Divinity Foundation with us today. He'll walk us through the ins and outs of the Canister, showing you how they operate and how to use them effectively in your projects. I'll go through that more on that shortly. But before that, let me quickly introduce what Coinstore Lab is. We are a leading accelerator in the blockchain space, focused on driving innovations by supporting visionary entrepreneurs. Our mission covers key areas like DeFi, Web3, and public chains. At Coinstore Lab, we believe in the power of collaboration and creativity. And this hackathon reflects our commitment to nurturing talent and shaping the future of blockchain. We're excited to see the amazing ideas that will come out from this competition. Next up, let me introduce the ICP Hackathon. This is a 7-week event running from August 10th to September 25th, and it's all about sparking innovations in the Web3 space. Organized by Coinstore Labs and ICP Hub Vietnam, it's a fantastic platform for developers and enthusiasts to showcase their cutting-edge ideas. Participants will compete in 2 main tracks, DeFi and RWA, and AI gaming, social fi, and NFTs. With a prize pool of up to $500,000, we can't wait to see the groundbreaking solutions that come out from this competition. So now, it's my pleasure to introduce our speaker for today, Elias Detler. So he's a software engineer at the Divinity Foundation. He'll be sharing his expertise on Canister smart contracts, providing us with valuable insights on how they function and how we can leverage them in our project. So please join me. Welcome, Elias Detler.
Hey, everybody. Thanks for the nice introduction. So yeah, I'm a software engineer at the Divinity Foundation. I work in the Utopia team. And today I have the honor to present Canister smart contracts to you. So let's see. Okay. So before we talk about canisters, I would like to start with a brief overview of the Internet Computer Protocol, just so you know the environment that the canisters run on. So here on the right-hand side, you can see the 3 main layers that are important to understanding the Internet computer. So at the very bottom, you have what we call node machines or replicas, and they are hosted by individuals around the world or by small companies. And what's important to point out is that none of these nodes run on centralized cloud infrastructure like AWS or Google Cloud. This is important because such big tech companies could turn off your service at will, or they could get hacked and other things. Then on top of those nodes, we have the Internet Computer Protocol, which connects these nodes and forms smaller subnets. And on top of the Internet Computer Protocol, we have this WebAssembly runtime environment. That's the 3rd layer here, which can host your Canister smart contracts. Now, if you compare the Internet computer to blockchains like Ethereum, you can see that those are completely different chains. So if you look at transactions per second, for example, you can see that ICP can process orders of magnitude more transactions than Ethereum. If you look at the transaction finality on Ethereum, it's like a couple of minutes that you need to wait to have enough block confirmations. And only then you can really be sure that your message will stay in the blockchain and that no fork happened. And on ICP, we have what's called instant block finality. So once a block is approved and broadcast by the network, it will always stay there. And this happens in around 1 second, once every second. We also have different subnets that have even faster block finality, around half a second, for example. Then when it comes to transaction costs, you can also see that ICP here, a single transaction costs like a fraction of a cent. And in Ethereum, you pay around $2 the last time I checked for a transaction fees. Now, those numbers vary a little bit from day to day and from season to season, right? But those are the rough numbers, and they're so different that yeah, it's really a completely different picture. Then when it comes to storage costs on Ethereum, if you want to store a gigabyte of data, you pay $15.5 million, which is, well, an insane amount of money, right? If you think about storing user data or images or videos, that's just totally out of the question on Ethereum. But on the internet computer, we can offer 1 gigabyte for about $5 per year. So it's really suitable to store images and all data on chain. Now, now that we know how the internet computer functions and how fast it is, let's talk about the Canister smart contracts. So canisters are an advanced form of traditional smart contracts that you might know from other chains, and they run in this WebAssembly environment that you see here on the right-hand side, and they can all run in parallel. And those canisters are the fundamental building blocks of the internet computer. So when you want to develop an application on the internet computer blockchain, you will mostly be busy writing those canisters. And you as a developer, you don't really have to worry about the layers below your canister, like the nodes or the internet computer protocol itself. You can really focus just on writing canisters. Now, on Ethereum, for example, the main language that is used to write smart contracts is Solidity. And on the internet computer, we can offer a large array of languages. And those languages might be familiar with you because they're also used in normal Web2 development. So for example, we have Python or TypeScript, JavaScript, we have Rust and C++, and the learning curve here is much more flat because most of you are probably familiar with those languages, whereas Solidity is really something that's unique to Ethereum and requires more learning. Now, if you're not a seasoned programmer, or if you're new to developing on blockchains, we also have a language that's specifically made to write canisters, and it feels very natural to write smart contracts for ICP in that language, and that's Motoko. So if you're new to ICP and in general new to programming, that's the language that I would recommend you to use. But if you already have experience with those other languages, it's also a very good idea to just pick up with a language that you already know. Now, as we've seen before in the slides, the internet computer is really capable of transacting and processing large amounts of data. And also a single smart contract or a canister on the internet computer can store up to 400 gigabytes of data. That's again unheard of for traditional EVM-based smart contracts. I think they can only store like a few kilobytes. So again, that's many orders of magnitude more that you can do on ICP. And what's also important is that a canister can really host any kind of software. As you will see later, you can host entire social networks on chain. You can host chat apps. Of course, you can do DeFi. You can integrate with other chains. And you can imagine any service that would run in traditional Web 2. You could host that in a decentralized way on the internet computer. Now, on top of that, canisters run at web speed. That's also something we will see later in the demo. So users can really access your canister by just Googling for your web page, and then Google will show them a URL, and people won't even realize that they're interacting with a blockchain right now because it's so seamlessly integrated into the Web 2 world. And the canisters are so fast that it feels like browsing any other website that's out there today. But everything here can run on-chain in a decentralized way, such that it's much more immune to cyber attacks and ransomware attacks and those kind of attacks. Now, let's take a look at some of the capabilities of smart contracts on the ICP. So on a technical level, smart contracts on the ICP are just WebAssembly modules. That's a bytecode format that's supported by all modern web browsers. And the internet computer uses this
Hey, Elias, I can't hear you. Are you lagging?
canisters.
Right.
Now, we also have cycles. Cycles are kind of like the gas fee on Ethereum. So when you hear cycles, it kind of translates to gas on Ethereum. However, we have what's called the reverse gas model. Now, what's the reverse gas model? You know, on traditional blockchains like Bitcoin or Ethereum, it's the user who has to pay when they want to interact with a smart contract. And on ICP, the user doesn't have to pay by default. So when you interact with a Canister smart contract, by default, you don't need a wallet, you don't need to sign transactions with MetaMask or whatnot. And you can just browse those smart contracts and use them for free. But it's the hoster or the developer of the smart contract who needs to top up the smart contract with cycles. And those cycles are then used to pay for the requests that come from users. So this is much more like it is in the traditional IT. So for example, when you go to apple.com, you don't need to pay to go to this site, right? You can just open it in your browser and you can use the site. You don't need a wallet. And the same thing is true for the internet computer. You don't need to create a wallet and approve transactions to access a website. You can just go there, use it, and the developer takes care of paying the gas fee. Now, canisters can also hold native tokens. So the native token of the internet computer is ICP, and it can transact those tokens from one smart contract to another. And we also have token standards, namely ICRC1 and 2, that is comparable to ERC20. So it's just a standard for tokens, and you can create your own token on the internet computer within a matter of minutes. Now, canisters can also interact with other blockchains, and that means that they can also transact Bitcoin or Ethereum or any other Ethereum-based tokens natively. So there's no need to create bridges or to centralized or for centralized management of sending tokens. It's really the canister itself that can hold those assets on the native chain and transact them. And because Bitcoin and Ethereum are quite slow when you transact those tokens, we also created digital twins on the ICP blockchain, and we call this chain key tokens because the keys are managed by your canister and the entire subnet that your canister is hosted on. And this allows you to transact Bitcoin and Ethereum or other ERC20 tokens much faster and much cheaper than on the native chains. But still, there's no centralized party involved. You only have to trust the internet computer itself, and it manages those tokens and the keys for these tokens for you. Now, I've told you that we have this three-layered stack on the internet computer, and each canister runs on a specific subnet on the internet computer. And as of today, we have 37 subnets, and we use those subnets to scale the internet computer. So if more and more people deploy canisters to a certain subnet, this subnet will slowly become full, and then we can create a new subnet which doesn't have any canisters in the beginning, and then users can deploy canisters to that subnet. And this is how the internet computer can scale infinitely. And of course, those subnets can talk to each other. So one canister on one subnet can easily interact with another canister that lives on a different subnet. And again, to the programmer, this is abstracted and you don't have to worry about routing. You can just call a canister with its ID, and the protocol takes care of routing the call to the correct subnet and to the correct canister. Now let's talk about some more capabilities of the internet computer. So as I've mentioned, your canisters run on sovereign infrastructure that's not owned by AWS or any other centralized cloud provider, but we have our own nodes that are brought to the network by numerous node providers around the world. On the internet computer, you can also create the most effective DAOs, decentralized autonomous organizations, and they have a very good framework, which we call SNS, that allows you to give away centralized control of a canister to a community. And then every time the community wants to change the behavior of a smart contract, you need a proposal, and the majority of token holders needs to agree that this is a good change, and only then, if the vote is accepted by the majority, you can change those services. Then we also have internet identity. This is a very convenient way to interact with canisters in a session way that's familiar to how you sign in with Google or Facebook on other websites. But here it's completely decentralized. Nobody is looking at your data, and also you're isolated from other applications. So there's nothing in the background that collects all your data. It's all hosted publicly on the chain, and everybody can verify that this is the case. And to sign in, you just need some biometric authentication. So like Face ID on your phone or a fingerprint sensor. There's no need to remember a password or a seed phrase. It's a really convenient way to interact with the Web3 world. And we also have what we call full stack decentralization. So because the canisters are so capable and offer so much storage, you can really host entire websites or even social networks, as we will see later, on chain, where all the assets, all the data, all the business logic is hosted on the blockchain. And canisters also can take advantage of chain key cryptography. Remember, this is the mechanism that allows a canister to have a private key and to hold funds and transact funds on other chains or sign messages cryptographically in general. And another amazing feature that canisters have, which doesn't exist on other chains, are HTTPS outcalls. So with HTTPS outcalls, your canister can seamlessly talk to the Web2 world. So for example, you could imagine that your canister gets some price data from Coinbase or from Binance. It simply sends an HTTP request to such a service that doesn't live on chain, and it gets those data on chain. And that's very straightforward to program, and there's no need to have some kind of oracle which can be hacked and is fundamentally centralized. Now that we know how canisters work and what they're capable of, I want to show you two concrete examples of some canisters that exist on the ICP blockchain. So first of all, we have the ICP ledger canister. And that's a special canister that maintains the token balances of ICP accounts. And we call those accounts principals on the internet computer. And this also shows a difference to, for example, Ethereum. So the native token of ICP is called ICP, and it just lives in a smart contract. Whereas on Ethereum, it's much more deeper embedded in the blockchain itself. But since ICP is so powerful, you can just write kind of a small sub-blockchain, which is this ledger canister, on top of the big blockchain. So the ledger canister is just a normal canister, if you will, but it's only responsible for transacting those tokens. And this canister lives on the NNS subnet. That's a special subnet where only system canisters are installed. And all the canisters there are controlled by the ICP community. And every time you want to make changes to those canisters, you again need a vote to make those changes. So no single entity can control the ICP blockchain. It always has to go through the consensus in the community. And this canister, as I've said, is responsible for transacting those ICP tokens. And the ledger is also compatible with ICRC1 and 2. And you can essentially copy and paste this ledger canister, change a few parameters, and like that you can create your own token on ICP. Now another canister that's very interesting is the EVM RPC canister. So this canister has been designed to facilitate talking to other EVM-based chains like Ethereum or Base, Optimism, you name it. and it provides you an on-chain API with which you can call into other blockchains. And you don't need to manage some API keys or accounts. That is all done by the EVM canister. All you need to do is pay with cycles. So you charge your canister with cycles, and then for some endpoints, the EVM charges the caller with some cycles, and you just need to attach those. That's much easier than if you have to create an account for an RPC provider and manage the API key yourself. And this canister also allows you to sign native transactions with the chain key cryptography, and it will then forward those signed messages for you to the correct RPC providers. And also you can use this canister to call multiple RPC providers at the same time, and then your results are much more trustworthy. Whereas typically you just call one RPC provider, but if this RPC provider tries to fool you, you have no way of knowing. But if you call multiple, then this canister will run like a consensus on them, and only if they agree, they will return the data to you. All right, now I'd like to quickly show you some canisters and some dApps that we have on the ICP. So the first one is Tagger. That's like it's like a social network that completely lives on chain. So all the assets you can see here, all the images, all the user reactions, all the text is stored on chain. And you can see you can just access this dApp with your web browser if you go to tagger.link. And you won't even notice that you're actually surfing the blockchain right now. So this is the first example. I recommend you check it out. We also have Open Chat. That's like a Telegram or a Slack that's running completely on chain and is managed by a decentralized autonomous organization. And again, every time that those canisters need to be upgraded, the community can verify the code that is written in those canisters, and you can have entire communities here. So this is one community for a meme coin that we have on ICP, for example. And yeah, everything is live here. You can send messages, everything on chain. So those are two dApps on the IC. Now I also want to show you the dashboard of the Internet Computer. You can find it under dashboard.internetcomputer.org. And here you can see all the blocks that are being produced by the ICP blockchain in all subnets. You can see we have around 45 blocks per second. And you can see we have about 5,000 transactions per second. You can see we have 37 subnets, many node machines, and also a lot of node providers. And you can even see how much energy the entire network is consuming. And if you scroll down, you can also see the canisters that we have on ICP. You can see we have around 500,000 canisters installed on the ICP right now. And you can see the history of that number. So that's a very useful resource. And if we take a look at the NNS ICP ledger canister, that was the one that I showed you before on the slides, you can see the interface that it exposes here. And for example, you can call ICRC1 name here. So this is a standardized function that comes from this ICRC1 token standard. And you can just call it. You can see it's almost instant, this feedback here, and you get the name of the token. Obviously, it's called Internet Computer. And yeah, you can see I didn't have to sign in with a wallet here or pay to call this Canister. It's just for free, and the Canister developer has topped up the Canister with enough cycles. Of course, you can also have more complex functions where you supply some arguments here, and also you can transfer here with your tokens. So the dashboard is really useful if you want to explore some canisters. And further down, you can see the entire interface of the Canister. You can choose a language of your liking here. I'm going to choose Candid. That's the native interface description language on the Internet Computer. And you can see there are a bunch of types defined. And at the bottom, you can see in the service description, you can see all the different methods that this Canister exposes. And yeah, you can call them from other canisters or from your command line or from the dashboard. The Canister doesn't really care. All right, then let's go back to the slide. I have two slides left. So if you start to develop on the Internet Computer, I can really recommend to forget what you've heard about other blockchains like Ethereum, and you should think much more as a traditional cloud developer or as a traditional software engineer. Because Ethereum can only store small parts of data on chain, but on ICP, you can really host all the software on chain. So with that, I have 3 QR codes here that where you can learn more. You can join our Discord. You can learn more about canisters or about the EVM canister in particular. And I'd be happy to take some questions now. Thank you.
All right, boy. Oh boy, was that interesting. Thank you, Elias, for the insightful presentation and share what Canister smart contracts have and can do. I do appreciate it. Was an amazing presentation. So before we wrap up this session, Elias, I have a question for you. Anything that you hope to see during this hackathon?
Yes, so I think the hot topic right now is the chain fusion topic. So I hope to see some cross-chain applications. So for example, you could build like a decentralized exchange that transacts tokens from one chain to another, and you could have the front end and everything hosted on chain on the Internet Computer, and you could transact Ethereum tokens, for example, all from ICP. That's something that would be amazing in my eyes.
Lovely, lovely guys to take note. All right. That's what Elias want to know and have a look at. All right. Thank you so much. So it's been a pleasure to have you on our workshop session. I would like to also thank you everyone who joined us. So before you go, be sure to check out the 3 QR codes that we have on our screen. So they will take you to the key resources, including our hackathon registration, our official pages, including the Discord channel as well, where you could ask questions and stay connected. So be sure to follow us and also follow ICP. And they do have a dedicated Discord channel that would answer questions as well. So you guys could just feel free to join either one of the Discord and they will answer the questions. So thank you everyone who joined and have a great weekend. Goodbye.
Thank you. Bye.
All right, that's it.